So here 1 iron plus 2 to plus 3. So with respect to iron, the change in oxidation state is 1. Similarly with respect to carbon, so plus 3 to plus 4. So actually here there are 2 carbons are there in this molecule. So per each carbon, one is oxidation state. For 2 carbon, the total oxidation state change is 2. So overall oxidation state change with respect to iron and with respect to carbon is 3. So hence the N factor for ferrous oxalate is 3. So here, and this is Fe, I wrote 2 here, and this is actually Fe, FeC2O4. And that is equals to, again, the number of moles of KMnO4, and here it is given in the question, that is 2 moles, 2 into, and what is the N factor for KMnO4? In acidic medium, KMnO4 N factor is 5. So hence now N is equals to 10 by 3. 10 by 3 means it is 3.33 moles. And in a similar way, we have to identify for Morse salt. In case of Morse salt, here iron plus 2 oxidation state and sulfur is in plus 6 oxidation state. So sulfur, it won't be oxidized further in presence of KMnO4. Only there is a chance to undergo oxidation with respect to ferrous ion only. So here only ferrous ion is converted to ferric ion. Now overall, and similarly the gram equivalence of Morse salt, and here FeSO4 ammonium sulfate dot 6H2O, and this value should be is equal to similarly the gram equivalence of KMnO4. And if we see here, and in this particular case in the Morse salt, only one iron in plus 2 oxidation state is changed to plus 3 oxidation state. So N factor for ferrous ammonium sulfate is 1 only. So number of moles into its N factor is 1, and similarly for KMnO4, as usual, it is number of moles is given 2 and N factor is 5. So then N is equal to 10. So in case of ferrous ammonium sulfate is a Morse salt, the number of moles required is 10, and in case of ferrous oxalate it is 3.3. Hence it is the first option, 3.33 and 10 moles respectively.